Okay, ladies and gentlemen, welcome to the 2023 FRQ. It's the free response question video. For the first part, we're going to be working with the graphing calculator portion of the test. Remember that in the test you have 30 minutes for both questions. In other words, you have 15 minutes per question. So let me get my calculator ready. Okay, let's start with question number 1. Here we're given the table. It says a customer at a gas station is pumping gasoline into a gas tank. The rate of flow of gasoline is modeled by a differentiable function f, where f is measured in gallons per second. It's going to be important. T is measured in seconds since pumping began. Selected values of f of t are given in the table above. Using the correct units, interpret the meaning of the integral from 60 to 135 in the context of the problem. Use a right-Riemann sum with 3 subintervals to approximate the value of the integral. Okay. The integral from 60 to 135 of f of t dt is going to be given by a right-Riemann sum. So basically the equation is f of x1 times x1 minus x0, which this is basically the height of the rectangle and this is the width of the rectangle, plus f of x2 times x2 minus x1 plus f of x3 times x of 3 minus x of 2. If we look at the first interval between 0 and 90, f of x1 is basically f of 90, and the width is 90 minus 0, plus f of 120 times 120 minus 90. Oh, and you know what? I made a mistake right here. We're not doing 0. We're doing 60, right? 90 minus 60. So anyways, plus f of 135. And then we have 135 minus 120. F of 90 is 0.15 times 30 plus 0.1 times 30 plus 0.05 plus times 15. Okay. Now, since we do have a graphing calculator, we can go ahead and punch everything in, giving us a total of 8.25. And now we just have to interpret the meaning. Between 60 and 135 seconds, 8.25 gallons of gas was pumped, or were pumped. Hopefully we're not penalized here by English, right? So that's what it is. Moving on to part B. Must there exist a value of c for the interval from 60 to 120 such that f prime of c is equal to 0? Okay, well, for this, since we're talking about a derivative being 0, we have to use the mean value theorem. The mean value theorem says that f prime of c is going to equal to f of b minus f of a over b minus a, as long as the function is continuous and differentiable. And because we're pumping gas into a gas tank, the function is in fact continuous, even if we don't have all the variables. So let's just go ahead and try to calculate this based on the given interval. F of 120 minus f of 60 over 120 minus 60 equals, okay, let me take a look at what f of 20 is. It's 0.1 minus 0.1 over 60, which in fact is 0. So yes, by the mean value theorem, there must exist a value of C such that f prime of C is equal to 0. Because remember what the mean value theorem says. It says that as long as a function is continuous and differentiable, the derivative, there's going to be a point C such that the derivative is equal to the average rate of change. So that's our solution. Okay, part C. The rate of flow of gasoline in gallons per second can also be modeled by the function g of t for 0 to 150. Using this model, find the average rate of flow of gasoline over the interval from 0 to 150. And here's the keyword, average rate of flow. Average value is equal to 1 over b minus a of the integral from a to b of f of x dx. And that's just me writing the equation, right? Because now we're going to have to apply it. So we have 1 over 150 minus 0 of the integral from 0 to 150 of t 500 cosine of t divided by 120 squared dt. And because we have a calculator, we can go ahead and plug this in, giving us the value 0.096 if we round. And that is it. We don't have to interpret the meaning of this. Okay. D. Using the model G defined in part C, find the value of G prime of 140. Interpret the meaning of your answer in the context of the problem. Okay. Well, we know what G of T is. So G of T is T over 500 times cosine of T divided by 120 squared. All we can do here is just go ahead and plug it into the calculator, right? You're going to be using, let me verify this, Math 8 to use your derivative. The calculator will take derivatives for you guys if you're going to evaluate them. So plug it in. It's going to give us negative 0.005. Now, what does this mean? At 140 seconds, the rate of flow of gasoline is decreasing at a rate of 0.005 gallons per second, or you can say per second squared. I'm just going to go ahead and spell it all out. Okay. Well, as you can hear, it's time for the next class. So I'm going to go ahead and stop the video right here, and we'll continue next time. Learn your concepts.